to part 7 of this series on trigonometry. You may be wondering, how many parts is this series going to have? And I think it's probably going to end up being 10. It's a big chunk of the curriculum at this level of maths in high schools and such. It is a subject that goes on and on. So if you were doing, studying maths up to age 18 at high school and then carrying on and doing maths or physics at college, you would be learning more and more aspects of trigonometry. These sine and cosine functions turn out to have many beautiful and really useful properties. So I definitely think it's worth studying this in some detail at this level. So what we're going to do in this tutorial is get a bit more formal and think about sine, cosine and tangent as functions of x. So we're going to think of drawing graphs, y against x, and we want x to be the angle, and we want to draw on these graphs what do sine, cosine and tangent look like as essentially graphs, as functions. So let me just kind of sketch these axes, but before I draw the functions, I'm going to try and motivate them for you. Okay, so just bear with me while I just set this up here. Okay, something like this. Okay. You might ask, why doesn't she just have all this ready before we start the tutorial? But I think when you're watching YouTube videos, it's sometimes quite relaxing to watch people actually draw things, and it just kind of gets you into a relaxed frame of mind. So that's my kind of logic for doing this during the tutorial. I hope you don't mind. You can always fast forward, I guess. But anyway, here we are. This is going to be the graph of sine x. This is going to be the graph of cosine of x, and this is going to be the graph of tangent of x. And for the purposes of these tutorials, I have to do curly x's. Right, and this is going to be 360 degrees here, all the way down. This is going to be 180 degrees. This is going to be 90 degrees. And this is going to be 90 degrees in between these two, which is 270. So certainly in the Scottish exam system, when they ask you questions about sine, cosine and tan as functions, they're nearly always asking about this range of angles between 0 and 360 degrees. In the next tutorial, which is also going to be about graphs, I'll probably just mention what happens beyond 360 and for negative values of angle. The answer being not very much, actually. All the information is in this range and it just gets repeated everywhere else. Now, there's a very natural question you can ask, which I think is a good question, which is, hang on, we in the, I think it was the second tutorial, defined sine, cosine and tangent, and we drew this right angle triangle. So they're only defined for angles that go between 0 and 90 degrees, because I can't go beyond 90 degrees because this triangle ceases to exist. And that is a very good point. So from what you've seen so far, we can't really talk about these graphs beyond this range of 0 to 90. So in order to think about sine, cosine and tangent for other angles, we need to actually make a different construction, and that's what I'm going to do right here. So I'm going to draw a circle. Okay, here we are, here's a circle, and I need a ruler. I'm just going to draw this construction here. Right. So I want you to think about the angle being between a point on the circumference of this circle and this origin here. And so I'm going to call this angle here x degrees. Okay. Furthermore, I want to choose the length of this radius of the circle to be 1. So we have essentially a circle of radius 1. This line corresponds to 0 degrees for this angle x, and then as the angle x gets larger and larger, when we get to here we're going to have 90 degrees. But then you see we can keep going, and as I bring this point round and define the angle x for larger and larger values, I'll get to 180 degrees, and then round to 270 degrees, and finally all the way back here at 360 degrees. And let me always, wherever this point is on the circumference of the circle, just drop down a line to make a right angle triangle. And you can see where this is going now, that we have a right angle triangle. In fact, I don't need that to be a dotted line given it's in red. So let's just do that, okay? Now, do you see now, because my radius of the circle, I've just defined it to be 1, if I say, well, what's the sine of x? It's the opposite over the hypotenuse in this right angle triangle, but the hypotenuse is 1, so actually this height is the sine of x. And likewise, the cosine of x is the adjacent over the hypotenuse, and because the hypotenuse is 1, this distance between here and the center will be the cosine of x. So as I take this point around, this height goes from 0 and grows to 1, and this distance here, as I take the point around, starts at 1 and shrinks to 0, and that will map out for us sine and cosine. So just to kind of give you an indication of that, if I take the point quite close to 90 degrees, this would be now x degrees would be this angle, and if I drop down that vertical and make a right angle triangle, there you see now this line here is sine x, and this little line here would be cosine of x. And you see how sine x is approaching 1 and cosine x is approaching 0. So as you take this point from here to here, you can just measure the height and measure this horizontal distance, and you would map out sine and cosine between 0 and 90. And this is what you would see for sine, and starting at 0 and going to 1, and then for cosine, starting at 1 and coming down to 0. Okay? And then the tangent is the ratio of those. The tangent basically is the it's sine divided by cosine. It's the slope of this line, and the slope starts at 0, it gets bigger and bigger, and finally the slope becomes infinitely large. So for the tangent, it will look something like this and go off to infinity. Okay? But the advantage of this construction is that we can now just keep going round and see what happens as we make the angle bigger and bigger. We just define sine and cosine to be these two things, the vertical distance and the horizontal distance. So I'm taking my point now into this second quadrant, angles between 90 and 180. I'm going to drop down this line. Again, just to remind you that the hypotenuse is 1. This is my angle x. My angle x now, you see, is an angle between 90 and 180, and I just define now this vertical line here to be the sine of x. And I define this line, the length of this line to be the cosine of x. So you see what happens now as I take this point round here, sine being the height of the point goes from 1 back down to 0, and cosine, which went from 1 down to 0 as the point went up here, now becomes negative and will go to -1. So cosine becomes negative and goes to -1. Okay. Tangent is going to be the ratio of these two things. You see the slope now is negative and goes to 0. So it disappears off to infinity, and as soon as you get above 90 degrees, it comes in from -infinity and will go to 0 at 180 degrees. So it's coming in here from -infinity. If you can just see that at the bottom of the page there. Right, let's just do the last two quadrants fairly quickly, because I can sense this tutorial's going to be a little bit too long. So we're just going to come this side now into the third quadrant of angles, drop down a line to this axis. This is the sine of x. This length here will be the cosine of x. My angle now is this crazy thing. That's my angle x degrees, which is an angle between 180 and 270. You see, as I bring the point round now, sine grows from 0 negatively, and it grows to -1. So when this point gets to here, the vertical distance here will be magnitude 1 and negative because it's underneath the line. So sine is going to go from 0 to -1. Cosine is going to shrink from -1 back to 0. You see, because cosine is the horizontal distance, and as the point goes round, it's going to shrink from -1 to 0. And tangent, the slope is going to be positive and become infinite again. So tangent actually exactly repeats what it did in the first quadrant. And finally, in the last quadrant then, if I just drop this point down, and it's very hard to draw the angle now, but essentially in that last quadrant, this is our angle x degrees. It's an angle between 270 and 360. We drop down this line to the axis, make a right angle triangle. This vertical line here is sine of x, and the horizontal line is the cosine of x. We see that as this point moves from here to here, the sine of x shrinks from -1 to 0, back to where it started. The cosine grows as I go from here to here with the point. The horizontal line grows from 0 to 1. And the tangent becomes, as the slope, or as the ratio of these two things, it is negative again and goes from -infinity to 0. Okay, so there we are. These are really, really important graphs to understand and to think about. This is the graph of sine x. This is the graph of the cosine of x. And this one you can get from the two above by taking the ratio, is the graph of tangent of x. I don't think it's helpful to just draw these without motivating them, so going through all this rigmarole of this diagram is just to motivate to you how we can define sine and cosine for angles bigger than 90 degrees. And you can see very clearly why they have the shape that they have. And the other thing that you can see is that there's tons of symmetry in these graphs. The way that sine goes up and down as you take the point round here is precisely the way it goes down and up as you go around here. The same with cosine. The way it goes from 1 to 0 is exactly the same as the way it goes from 0 to -1. So there's lots and lots of symmetry in these diagrams. And in a couple of tutorials time, when we start to solve trigonometric equations, we're going to really exploit all of the beautiful symmetries in these graphs. So let me stop there because I feel this is quite a long tutorial, and in the next tutorial we'll just talk about transforming these graphs, but we see that the shapes will always be roughly the same. So that's all for now, and I'll see you next time.